All right, so in this video, I'm going to be going over this FRQ, which is the 2014 number one. This is another 10-point FRQ, realistic to what your first one will look like. Part C is a little specific on evolution and natural selection, but the first one are going to be very, very helpful. Or I should say part A and B are very, very helpful. So let's take a look at this one. It's talking about stem trichome density. Trichomes are just these things that are going to be attached on the plant. A student counted the number of trichomes on the stem of 6 plants in each of the 3 different populations. Student used that data to calculate the mean trichome density. So those are the number of hairs per square centimeter. For each population, the results are provided. So plant 1, 2, 3, 4, 5, 6, so 6 plants. They took the mean trichomes of each, and then they calculated the standard error of the mean. So then this one tells you on the axes provided, create an appropriate labeled graph to illustrate the sample means of the 3 populations within 95% confidence, i.e. double the standard error of the mean. Now, if you look at what they gave you, this one was pretty sneaky. They give you the standard error of the mean, but you actually had to multiply those each by 2 because that's going to put you at that 95% confidence. So I kind of already set the graph up that your y-axis is going to be your trichome density. We got plant 1, 2, and 3. So the mean for plant or population number 1, sorry, I should clarify this, that this would actually be not plants, but populations. So population 1, population 2, population 3. So for population 1, the mean trichome density is 9. So I'm just going to plot that one right here. And to get that standard error bar at 95% confidence, I have to double the standard error of the mean. So you did have to actually double it, unless it said plus or minus 2 standard error of the mean. So that means I have to go up 2. So this is going to take it all the way up to 11 because I'm doubling that standard error of the mean. If this is 9, this is going to take it down to 7. So that is that particular error bar. Population 2. They have a mean of 11. So for population 2, that mean is of 11. And with that, standard error of the mean is 1. So we have to double that. So we're going to go up. If this is going to be 11, it's going to take that up to 13. And this is going to take that down. Here's you're going plus 2, minus 2. This one is also plus 2, minus 2. You don't have to put that just to kind of help us as we analyze the rest of this. Population 3, the mean is 14. So the number of trichromes on this one goes all the way up to 14. And if I am correct, yeah, it's the standard error of the mean is going to be 2 for each one. So we have to go up 2 and down 2. So plus 2, minus 2, right? So this would have gotten you 3 points because you have your axes labeled, it's graphed correctly, you have your error bars graphed correctly. Always remember to label your axes for sure and label them correctly. So there's your population, it all looks good. So that got you 3 points for this. Now when you look on to part B, based on the sample means and standard errors of the mean, identify the two populations that are most likely to have statistically significant difference and the mean, and justify your response. So identify the two that are the most different and justify your response. So when you look here, if you look at the means are all different, but kind of like the previous problem I had posted, when you look at the actual error bars, right? These error bars overlap. So when you think about these two, population 1 and population 2, those error bars are overlapping. So you can't state that these two are different enough. So even when I look at, and here's the key thing, when I look at the error bars overlapping on population 1 and 3, the error bars never overlap. So the fact that even when I consider the error that was graphed with population 3 compared to population number 1, there's no overlap. So to get this answer correct for part B, you would have to state that population 1 and 3 are different. And that gets you 1 point. And justify your response. The response is just basically talking about the error bar. So that when you're at plus or minus 2 standard error of the mean, they don't overlap. That's critical, and that's basically what you needed to get, and what you had to state to get those points. So that got you that second point. So that's your first 5 points coming from this one. Now C, I'm going to put a little asterisk next to C because it's one of those things that you're not going to be specifically tested on. They could throw in an evolution question if they decide to, but it wouldn't be specific. This one is a little specific to natural selection, more so on the scientific method. But it says describe the independent and dependent variables and a control treatment for an experiment to test the hypothesis that a higher trichome density in plants is selected for in the presence of herbivores. Okay, so they're going to test that a higher trichome density is going to be selected for in the presence of herbivores. Okay, so herbivores, if you don't remember, are going to be species that eat plants, right? Identify an appropriate duration of the experiment to ensure that natural selection is measured and predict the experimental results that would support your hypothesis. So there's a lot going on. So it wants you to identify the independent and dependent variable. So that's going to be 2 points. It wants you to identify a control treatment. And it wants you to test that hypothesis that higher trichome density in plants is selected for. What's a good duration and the predicted experimental results that would support that hypothesis. So to explain this one, I'm just going to go through the rubric on the College Board, just because there's 2 scenarios that can earn you some points. So when you're looking through this one, if you're saying your independent variable is in the presence of herbivores, okay, what are you measuring? Well, then you're going to be measuring the trichomes that are on the plant themselves. The control group would be having a group without any herbivores. But notice the duration for whatever scenario you're going with. To ensure natural selection has taken place, it has to be at least 1 generation. And the last thing on the prediction, if you increase trichome density relative to the control, basically means the more trichomes, the more they're going to be selected for. That was essentially your prediction, all right? Now, again, if you're going that route, that you're controlling, you as the researcher, you're able to add in herbivores, well, what are you measuring? You're measuring how much trichomes are still available. Again, your control group is if you set up a group of plants without those herbivores, the duration of more than 1 generation, you're going to expect trichome density relative. You're going to have increased trichome density because it's going to help protect the plant. Now, in the second one, the second row, let's say if your independent variable would be plants that you can actually control the amount of trichomes. So your dependent variable, what would you be measuring? So in this case, you are just looking at the addition of the trichome density of the plants. That's what you can control. Your dependent is just, do those plants survive or do they not? That's what the reproductive success is stating. So you have your trichome density. That's what you can control. You're measuring, do those plants reproduce or not? What is your control group? Those would be plants without trichomes or those with lower ones, because again, that's what you are controlling in this row. Again, more than 1 generation to see if it was successful or not. And what do you predict would happen in this case? This would be the size of the population with higher trichome density will be larger than the control. So they're both stating that increased trichome increases the fitness or survivability of the plants. It's just how it was measured. So that was a big one. There's 5 points, but just making sure that you're able to identify independent, dependent, and control was really the key thing on this one. But like I said, the focus of this was really on the scientific method. And yeah, I hope that was helpful.